Hi, this recording is just to help you with how to enter some of these scatter plots into GeoGebra. Alright, so the first thing here, it says the calculator screen shows the graphs of a linear model and a quadratic equation. Model for the data below. Which model better represents or fits the data? So we got to enter this, and technically it gives you all of that, the steps there, entering that into a graphing calculator. Usually these are steps for Texas Instruments calculators, so a TI 83, 84, 86. These are the general steps for those. If you don't have a graphing calculator, it's okay. We can still go ahead and do these using GeoGebra. So the first thing is we got to keep in mind that 0 is representing the year 1990, and then these are in billions of dollars. So we're going to enter these points 0, 8.8 to begin with. So when I go to GeoGebra, notice the website up here. I'm going to hit the GeoGebra Classic app here, and that's going to open up a new screen. Once I wait for this to populate here, I'm going to go ahead, click out of that, and I'm just going to hit in the input bar. So 0, 8.8 was our very first point. So notice I just plugged that in here. I'm going to hit enter, and it's going to plot the point. Now you may not see it because we have to drag this around. Look, but there it is up at the top of the screen there. So I'm going to go back, find my next point, 10, 17.6, and I'm going to put that in and hit enter. And again, we may have to zoom out, so using this last icon here, hit that zoom out, click on the graph a couple times until you can kind of see those points coming into view. The third point is 2053.8. Hit enter, and again, we may have to zoom out a lot to see that. The fourth point is 2261.2. The next point is 2478.5. And 2689.7. Oopsie. Alright, so for this first one here, we can kind of generally look at the graph and say that's starting to maybe take the shape of a quadratic equation, or at least half of a quadratic equation. There is kind of a curve here, so we can go ahead and express that we think that might fit better. When I go back here, it does say I can use Desmos for the quadratic regressions. So if I open up or click on that Desmos link, this is going to type in the points that I had in GeoGebra. We can go ahead and get that equation as well. So I'm just going to copy 0, 8.8 into the charts over here. So I'm just going to transfer these numbers real quick. Now I'm going to erase the rest of the numbers in the chart. Alright, and then with that being done and our points being entered, we can scroll down and see the values for that quadratic regression occurring for A, B, and C. So if we think it's going to fit the quadratic regression better than a linear, we would want to use these values for A, B, and C into our formula ax squared plus bx plus c, which we see at the top here. If we do think it's a linear regression instead of a quadratic regression, we can come back to GeoGebra and we will connect a line or create a line, and we're going to select 2 points that we think are the best representation for this line. So maybe point A and point E, and that's going to give us our equation here for that linear regression versus the quadratic regression. So I do think that the quadratic regression fits the data points a little bit better. So I would probably come over to this one and use the equation here for the values of A, B, and C. Alright, following those instructions should help with questions 1 and question 2.